Hey folks, this is Mr. Woodward. This video is the first in a series on Newton's laws. Newton's laws are all about forces and motion, and so in this video I want you to think about, what do you believe about the way that things move in the world and why? First of all, what do we mean when we talk about a force in physics? A force is simply just a push or a pull. Okay, that's our really simple definition. If you're pushing something forward or pulling something backwards, or pushing something up or down, or pulling something left or right, you are applying a force. So let's look at some common statements pertaining to notions that people have regarding force and motion. Here's 7 statements. Can you identify the false statements? Number 1, a force is required to keep an object moving in a given direction. 2, an upward moving object must be experiencing, or at least usually does experience, an upward force. Number 3, a rightward moving object must be experiencing, or at least usually does experience, a rightward force. Number 4, a ball is thrown into the air and is moving upwards and rightwards towards its peak. A ball experiences a force that is directed upwards and rightwards. Number 5, if a person throws a ball with his hand, then the force of the hand upon the ball is experienced by the ball for at least a little while after the ball leaves the hand. Number 6, a cannonball is shot from a cannon at very high speed. The force of the explosion will be experienced by the cannonball for several seconds, or at least a little while. Number 7, if an object is at rest, then there are no forces acting upon the object. If you're following along in this video on the notes sheet that goes along with this, then you should pause and mark these 7 statements as true or false based on what you already believe. You will get a lot more out of this video if you really think carefully through these statements and mark them true or false before moving on. So let's take a look at number 1. A force is required to keep an object moving in a given direction, right? It's actually false. A force is required to move an object in a given direction, but not to keep it moving in that direction. For example, if you kicked a soccer ball in the middle of outer space, right, this is a major hypothetical, it would move outward from your foot in a straight line until it reached the edge of the universe, right? Without friction or air resistance, there would be nothing to stop it. So the force that you apply when you kick the soccer ball pushes it at the beginning, and then as soon as the soccer ball, leaves your foot, it actually just keeps moving forward forever and ever. Doesn't need that force to continually keep it pushing. Let's try number 2. An upward moving object must be experiencing, or at least usually does experience, an upward force. So you could think about maybe like throwing a ball upwards in the sky, or maybe an elevator that's moving upwards. Okay, must it be experiencing the upward force, or at least usually does it experience the upward force? This is also false. An upward moving object must initially receive an upward force. We talked about that with number 1, but it does not need that force to continue rising. For example, if I throw a ball straight up in the air, it actually experiences a downward force of gravity while it rises. It has the upward force while I throw it, but then as it's moving through the air, there's that gravity upon it at the same time, right? And actually gravity is acting on the ball even before I throw it. Let's try number 3. A rightward moving object must be experiencing, or at least usually does experience, a rightward force. So maybe think about like a car that's driving to the right. Must it be experiencing a rightward force in order to move to the right? This one is also false. So when you're driving, every time you take your foot off the gas, you remove the force that's pushing the car. However, the car continues to move forward even without that force. So you don't need a rightward force to keep an object moving to the right. It must not be experiencing that force at all times. Okay, how about number 4? A ball is thrown into the air and is moving upwards and rightwards towards its peak. So now maybe instead of throwing it straight up, you're throwing it like throwing a fly ball or something. The ball experiences a force that is directed upwards and rightwards while it's moving towards that peak. True or false? Also false. While the ball is thrown, it experiences a force that is upwards and rightwards. However, after the ball is thrown, the only force on it is gravity, which actually acts downwards, and there might be some air resistance on that ball, which would actually be acting down and to the left, which would be opposite the direction that the ball is traveling. So it doesn't need an upward and rightward force to continue moving towards its peak. All right, we haven't found any true statements so far. Let's see if there's a true statement hiding towards the end of this list. Number 5, if a person throws a ball with his hand, then the force of the hand upon the ball is experienced by the ball for at least a little while after the ball leaves the hand. In other words, how long does it take the applied force when you first push something or throw something? How long does it take for that force to go away? At least a little while, right? False. Once the ball leaves the hand, the force is no longer experienced, okay? So that would be a contact force. Once contact is broken with the hand, the force pushing the ball goes away. Okay, still looking for true statements here. Number 6, a cannonball is shot from a cannon at a very high speed. The force of the explosion will be experienced by the cannonball for several seconds, or at least a little while. Okay, so what if something is going at a very high speed? Does that change things? And in this case, a cannonball has to go through a tube, right? While there's an explosion, and then the cannonball goes through the tube or the muzzle of the cannon, and then it exits out the other side. So maybe now the force is experienced for a little while. And so to this one, I'll say sort of. The part that I'm crossing out here, right, is for several seconds. The cannonball only experiences the force while it's in the cannon, which is only a few milliseconds. Once it leaves the cannon, right, the tube, the muzzle of the cannon, the force is no longer applied, and the cannonball moves forward by its own inertia or its own momentum. All right, last statement. If an object is at rest, then there are no forces acting upon the object. You most likely, right now as you're watching this video, are at rest. You're most likely sitting in a chair watching this, okay? So think about yourself. Are there no forces acting upon you right now as you sit at rest? Also false. A resting object must experience at least 2 balanced forces: gravity pulling down and some sort of upward support force. So for you, it's probably your chair, which is supporting you upwards. And you'll learn later that that's actually called a normal force. So even objects at rest experience forces. So how do we summarize the rules here about forces in motion? Well, it's Isaac Newton's first law of motion, which is commonly stated, and this is not how he originally wrote it, but this is sort of a summary of the general ideas. Objects at rest remain at rest, and objects in motion remain in motion unless they're acted on by unbalanced forces. Okay? So an object that's moving is going to keep moving forever in a straight line unless there's a force to bring it to a stop. Similarly, an object that's sitting at rest is going to stay at rest. It's not going to spontaneously move unless there's some outside unbalanced force that pushes or pulls it into motion.